Okay, so gravity effect on fluid pressure. So actually use the formula P equal to F per A also, got from top and from bottom. So other than that, you need to use W equal to mg. Okay, so you need to find the rho. Rho is mass per volume. Okay, so how to measure volume? If you lazy to measure the volume, you can buy any product which already have the weight at the tin. For example, got the sample of document. Yes, after this. Okay, so that is the sample to study the fluid principle concept by creating the experiment. So your job is to create an experiment in the assignment. Number 2, to propose a model or prototype of the application of fluid principle by using household object. This one not necessary. If you don't have it in your house, you can buy. Miss, can I do this experiment and use 3 different objects? Yes, can. Can. Okay, wait. After that, or item purchased from hardware or hobby shop, hobby store. What item you want to purchase? For example, pipes. For example, wood. Wood, if you want several size, you can ask the hardware shop to cut for you also. Okay. If you then the how to weight the scale. Weight the scale normally must use kitchen scale. Because kitchen scale can measure the small weight, not the one that is you measure for yourself. The weight scale for yourself cannot because too big. Maybe minimum 1 kilo, but you are using small item, so must use kitchen scale. Okay, understand kitchen scale? Using a bottle and straw, simple home experiment also can. But the more complicated it is, the more marks Samuel. Okay. Okay, next number C. To demonstrate the proposed model and must be created solely by student. How I know student do or mother do, I also don't know, right? But during presentation, you must be confident when you present. Okay, so you cannot during presentation day, you say your experiment cannot work. Okay, got this problem, that problem. So that is why I ask you to record as a backup. So during the day, you open that backup video. Okay. And then task to be done, complete a 2,000 word report about fluid application. About only, not necessary. Okay. 2,000 word, not necessary. That is estimation. Okay, after that, pages of the report must be properly numbered. Later I check the content, page number 10, you mention table of component. Then when I open, it is not the table of component, it is something else. Okay, so this shows students are doing the work last minute. And then table of content and list of figure. You have a lot of picture later, okay? Picture of your component, picture of the kitchen scale, which kitchen scale you use. And then picture of the items. Okay. If you use the ring have many size, right? The one with the stone is heavier. The one without stone is lesser. So ring, if you have many different ring, you can use also as the experiment component. Okay. After that, explain the chosen fluid principle in form of statement. Because some student, when they send the formula only. They don't send in the terms of paragraph. So both must have. Okay, that one you can copy from the slide also. Mathematical form. Mathematical form don't copy later become blur. So try to type. Okay, type you know right how to type. I assume you already know. Okay, if you don't know, you go to insert. Okay, go to equation. Okay, equation just click also can. When you click equation, this will come out. Let's say you have P equal to F per A, right? So you type here. Click here. Wait Dulu. Okay, so P don't have the fraction. So P equal to F per A. Simple only, right? Formula. Then next to it, don't type anything. Enter. Do again. Insert equation. Do again. Then only it will be under it. Okay. If you copy from somewhere, let's say you copy this one lah. Okay. Copy. Cannot. If copy from Word, still okay. Sometimes copy from PDF. Then it will be different font, you see. This one Calibri 11. This one also Cambria Maths. So you need to select all, go to Times New Roman. Wait Times, why cannot? Times New Roman 12. Oh, cannot. Okay, I think equation cannot. So anything that you copy from internet, normally it will be Calibri 11. Okay, in the question, all must be 12 size times New Roman. And then spacing. I hope you know spacing also. Many people don't know. This one delete first. Okay, after you type, right? Then enter, type. So this one, go to here. Choose 1.5. Don't choose 1.15 or 1. Okay. So this simple thing, sometimes second marker will minus mark. Okay, so unnecessary you will minus your mark for what, right? Don't do that. Okay, other than that, okay, number 1, explain the fluid principle in a statement. Okay, settle. Propose example of its application and principle. So, for example, you choose Archimedes principle. So, what are the example of principle application which use Archimedes? Must explain. Okay. Just type in Google example of Archimedes application. Then all come out. You choose which one you want. Okay. And then propose simple model with demonstrate the physical principle of the application using items found in your home. So this, it is not compulsory everyone to use the one with water. Even though it is fluid principle, you can use air also. Okay, or gas. Okay, other than that, explain the step. Step must be in passive voice. You know passive voice, past tense already. Because you already do the experiment, then only you will do the report. Step must be in passive voice. What happen if you active voice? Marks will be reduced. Okay, for example, measure the pail weight. Okay, so your statement should be, the pail is being measured with what? Okay, it must be past tense. Okay, any report must be past tense, any subject also. Because you already do, then only you do the report. Okay, so explain step by step. Number 1, number 2, number 3. I have some student who send me in paragraph form for the step. Last time you do in the school, got step in paragraph or not? Don't have, right? Normally step are in number. Number 1, measure all the components to be used. Number 2, calibrate the measuring scale. The kitchen scale. If digital cannot. You know kitchen scale can be pressed become 0. Yeah, electronic scale or kitchen scale. For example, first you press 0, right? Become 0. After that, you put, okay, let's say, you put a cup on the weight scale. Okay, but then you want to put the water inside the cup. You don't want to measure the cup weight. So kitchen scale, after you put the cup, you can press the 0. Press the 0, then it becomes 0 back without measuring the weight of the mark. Okay, this one the mark. Then you pour the water, right? Okay, so when you press the 0 button, the scale will only measure the water, not the mark. If not, you need to minus. First, you measure the mark. Let's say the mark 0.3 kilo. You can change the scale also. 300 gram lah, for example. Okay, 300 gram. Then when you pour the water, it becomes 350 gram. So 350 you minus with the 300 gram. Become the water weight is 350 minus 300. 50 lah. Okay. So that one old style method. New method you can press the 0, so it will not include the weight of the mug or the bowl. Okay, so that is the special, not special so much lah. It is kitchen scale or electronic scale. But electronic scale for human, I think cannot. Only for the small ingredient, kitchen ingredient. Normally people measure the flour. Okay. So what are the steps that you do? Calibrate the kitchen scale. Old method, you will put the needle to 0. Now no need. Okay, or press the 0 button enough. What is someone doesn't has kitchen scale? So weight with human scale. Not so accurate. You still have more time to do. You can order from Shopee. Wait. The weight for bag, I'm not sure. I think that one more cannot, right? When you want to go to airport, you weight your bag, right? Using the springs type lah. But I think that one more heavier. Cannot, I think. Okay, so try to find it. What else? Report the result obtained with the conclusion. Okay. Next is presentation. A 10-minute presentation of your work is presented by using Microsoft Teams. Demonstrate the model which you have designed using the required medium in front of your class. Use iPhone, I'm not sure, Lim. Because I'm not using iPhone also. Use iPhone, then put the thing on iPhone, is it? Wow. Maybe you can show video, Lim. Then when we can learn together. Wait, I find a suitable video. Must install application. Oh. Okay. Okay, now we will watch one of the video. Last time can do in the APU. So student do the experiment in the workshop at the first floor.
Inversely proportional to the water pressure. So I designed this model in original. And when you open equal water pressure, the water will, this water level will go up. This is because then since water is in since the water is incompressible, so it follows the continuity equation, which is area is inversely proportional to velocity. So I put two pipes with different cross-sectional area. So the smaller one will, in the smaller cross-sectional area pipe, the water will flow faster than the one with bigger cross-sectional area. So as you can see, since this is flowing faster, so the pressure here is lower. So you can see the water level is a bit lower than this one. This because this because since the water pressure here is lower, the atmospheric pressure from outside is higher than the water pressure here. That's why it pushes the water downwards. And since there's no big difference because I use two pipes with a slightly different cross-section area, because the diameter for this pipe is 20 mm and for this pipe is 25 mm.
Okay, so the time use is just 1 minute something, right? But there are some weakness which, for example, not mentioning the size of the pipes. Okay, what are the component used? Which principle is used, not highlighted? Okay, so within if your video, if your presentation is short, like 5 minutes, so another 5 minutes will be question and answer. Not only question from me, other student also can ask you. Okay. Okay, now we watch another one. Hmm. Okay. So the other one is regarding the report. Okay. What is that? Is it necessary to record video or we should explain directly in class? Oh, video is for those who are not confident to talk in class or as backup. Backup means maybe yesterday he do the experiment can work, today cannot work. So the video must be backup to play during that presentation day. Okay, so now we look at one of the sample that student do. Okay, methodology and result. Procedure. A model was built as shown in figure 10. So figure is important. Next to the figure, you don't just put figure, you must have a title next to it. So for example here, model only. Okay, or prototype. A model was built as shown in figure 10. Tube A, B, C, D and E were labeled from right to left. A is from the shorter orange pipe part. Because she don't label at the picture itself, you know. So in the procedure mention A, B, C, D, E. But in the picture not labeled, right? Which one is A, which one is B, which one is C, D and E. But she have listed A is from here, from the orange. So A, B, C, D, E. It is better if you label and put arrow to the diagram. Okay, so I hope your class will do a better labeling in the figure. Next is the arc circle of the plastic bottle for the whole ABC were measured and marked on a string. The length of the marked string was measured by a ruler. If you have a measuring tape like the one used by the tailor, you know tailor to measure to make clothings, that one is more sufficient because ruler is straight. If your object straight, okay. If your object curve, not so accurate. So better you mention measuring tape, okay, instead of ruler. Ruler not so professional for engineering science subject. Okay. The reading of the arc circle are recorded in table 1. Next, diameter of the pipes for hole D and E were measured using ruler. How to measure using ruler? Can lah, because this one small, right? Okay. So you measure the diameter, then you can find the radius. Divide by 2. Reading were recorded in table 1. Apparatus was put in horizontal plane. There are some experiment which you need to put the apparatus in vertical plane. So one on top of each other. Okay. The water flow was allowed from a source to the pipe, which near the hole A for the apparatus, the water flow was continuous. So here don't mention water flow become constant or sometimes fast, sometimes slow, not mentioned. So all this detailed information is important in any science experiment. You must mention which one is assume what. Assume no wind at that time. Assume water flow is stable. Okay, here mention was continuous only. Fast or slow, don't know. Okay, the water level indicated at the transparent plastic hose A and E were observed and marked down the level of water. The marked water level for A to E was measured by string and ruler respectively. By string for what? By string for what? Because the thing is curved, right? So maybe she used spring, after that the string mark and then put at the ruler. Okay, so it is better to use the measuring tape which is flexible like the one used by tailors. Okay. Velocity of water flow was calculated for A, B, C, D, E. Result is recorded in table 2. So since there are 5 hole, to have 5 row here. Circle arc, diameter, radius, area, then water level. Okay. So the calculation is not included in the result. She have used the calculation outside it in another table. Calculation on the velocity of water flow. Okay. See how complex the mathematical is? How many points we need to insert in it? 5. Muhammad Saad, better to have 5. Okay, after that CD, DE and so on. So this is a good report that I show you. Okay, with many calculation. Okay, then discussion. This experiment was using the Bernoulli's principle. Equation of continuity and Bernoulli equation has utilized to obtain the velocity of water flow or the pressure for each point. Okay. So, but provided you are measuring velocity, so you must have something which is constant, which is the water that is not mentioned in the report. Okay. So she want to tell that for experiment here, okay, it depends on the small size here, area here, because all this is the same size. Okay, so which one has the highest velocity? Look at this summary of calculated velocity. E. E is 1.17 meter per second. Okay, where is E? So if you label here better, right? So E is here. And then why don't you take this table? Next to it is the picture, so you can compare together. Now I read this table, then I need to scroll. Some more words because now we mark online, not this style. We mark, then we need to Next page, next page, next page, right? So you can copy this. Copy this, put, can put here. Wait ah. Besar pula. Okay, this one if you difficult to move the figure, you choose this one, tight. Okay, or in line with text also can. Wait ah. I'm trying to move it here. Not layout. View side by side. Mana tadi? Something like that lah. Okay. So, when people refer to your table, okay, when people refer to your table, at the same time, they will see at the picture. Okay. So, E here have the most velocity. Okay, because of what? Table 3 shown a summary only. The mass of water that enter the tube in 1 second is the same as the mass of the water exiting the tube per second. Okay, so Bernoulli equation state that these equations are used to find out the velocity of water. So area is the biggest here. Here is a bit small at the D, a bit only. But here quite different, right? Double. 0.5 here, 1.1. But do you think the discussion is enough? Discussion doesn't mention, or maybe at the bottom. Here. Point E has the lowest water pressure and it has indicated by the lowest water level in the transparent plastic hose due to the smallest cross-section area for E and the highest velocity for the water flow. Smallest velocity correct or not? Here highest. Smallest cross-sectional area for E. E, from what I see, is the biggest. I think she meant A. Yalah. That's why whatever you provide the data must have paragraph and talk about it, but make sure it is correct. That is why better to have the data and the picture next to it. So when people want to check correct or not what she do. Okay? We cannot just accept blindly what you submit. Okay, that is our job. Because second marker also, if I don't find out, second marker also will find out. Velocity at A should be highest. A. At the small area. You use logic I mean explanation in table form. Can also. Explanation in table form also can. Okay, so I just want to show that she have a good report. But maybe during writing, she will confuse and write something else. So check back what you have written. Okay. After that, the model was built up by plastic. All this I think should have in the beginning. I think don't have. Table of component use. Okay, before procedure must have component use for experiment. Okay. Because maybe by looking at the report, another person will try to do it also. So before they do the experiment, they will see what component to take. To take or together lah. Okay. Yes, can. Explanation can be in table form. Lim Wei Huan. Okay. Other than that, although the calculated velocities for point A to E have not shown a continuous increase situation, the velocity in pairs have proved the statement of Bernoulli's principles. The increase of the cross-sectional area leads to decrease in the water velocity. So, here the statement okay. Increase cross-sectional area leads to decrease in water velocity. This statement is correct. But in here, data, small area at the A have small velocity. So this should be on top. I also don't know whether you make yourself or you do yourself the experiment or not, right? But you must provide the correct data. Okay, you take from somewhere, you take from internet the data also, I don't know. I won't go to your house and measure back the thing. But don't make a wrong data. Okay? So this is a sample for a wrong data. One more. Wait. Sama juga. Oh, okay. Put there. Okay. Next, we will see another another report. Okay, I don't want to see any of you to will be sending me this type of report. Okay, suddenly the content is sharing with introduction page. Okay, don't do that. Content should be one page of itself. And then content don't have pages. Okay. After that, this one. This is not 1.5. 1.5 will look like this. This one is one only. Paragraph spacing. Other than that, methodology, procedure. Okay. Place all the experiment for the experiment on the table. What is the wrong thing there? Anyone can detect? What is wrong with this procedure?
Need to be past tense.
Yes, need to be past tense. This one all present tense. Check if all the pieces of equipment are functioning well, and so on. If you don't know how to create the procedure statement, go and find in a research. In any books or internet. Okay. Result. Result, what is wrong with this result? Result, lazy to type. Result is handwritten like this. Handwritten okay, but then the real thing must type. Maybe want to show he's doing the calculation himself, not copy from book or from internet. That is good. But this one is extra. You can put at the back for appendix of your report. Not inside. Okay. Next, the table. Table, volume, time, velocity, cross-sectional area, discharge. So, if 3 looks like so minimum word limit, just now 2,000, right? 1,005 lah. Alam, if you don't know which part to write so much, you can write much in the example of principle and application. Okay? You take from internet, but you must rephrase. Okay, rephrase. Okay, for example.
Ma'am, how we can take out the area of a particular object?
How to take the area?
Yes, ma'am.
How to measure or what?
Yeah, how to measure, how to calculate the area.
How to calculate the area? Object is what? Volume. For example, if the object like this, right? So it is cylindrical shape. Then cross-sectional area becomes circle. Circle formula pi r to the power of 2.
Okay.
So you need to measure the diameter only.
Ma'am, can you explain this thing? I have sent to you the picture.
Send to me the picture. Why opposite? In this section, you should describe the model you have created. Yeah, just now already tell you. What you mean? No need to
Saying that
print.
it's not-
This is
Okay.
for non-online one.
Okay, ma'am. Thank you.
Send online only. Send in Moodle. No need to print.
Thank you.
I also confused. Which one you want to ask? Okay, for the word, how to make it longer. Okay. For example, your experiment is about Bernoulli principle. Then, talking about scientific principle, also a lot of wording already. Here copy but blur. Don't copy with blur like this. How to make it not blur? Okay, for example, you copy this. Here. Then right click. Go to crop. Crop. The wording is blur. The picture still okay, not that blur. Crop nicely. Settle. So, this is clear. Other thing, type under this. Figure what? Figure 2.0 and then put the title. Okay, title here. So, you know how to use snip also, right? Snip. Who don't know? Okay, let's say I print screen this. And then I copy to this. I think you are better than me in all this thing, right? Okay, so this one, right? Then you click. Snipping tool. Snipping tool. Difficult lah. Better you use crop lah. Okay, crop. You don't want that one. You want this one only. So, it becomes neat. When you want to enlarge it also, it will not be blur. Okay, it will be maintaining, not become smudge or not clear. It is still clear. So, try to do that method. Okay, if you want to copy from anything. Okay, wait just now this one. Okay, application. In this part, I will be talking more about how various situations where Bernoulli principle applies. This one, sentence also grammar problem. So, I want you to install Grammarly. It is free software. Copy data from Google can, but must put the citation. But must rephrase. So that your plagiarism not high. Okay, rephrase. Word of I, you, they, all cannot in report. Okay, I. In this part, I will be talking more about how various situations. No need to mention I. Okay, so your sentence should be various situations can be used to apply the Bernoulli principle. So make a better words. If don't know, open Grammarly. Okay, I don't know you have used Grammarly in other subject or not. So here, talking is present tense. Okay, suddenly have were here. Where suppose. So directly change there. Then at the bottom, figure this taken from this. But the format I think wrong. Okay, so Here also wrong spelling. Use Grammarly, can change spelling, can change grammar. See, got 2L. Okay, so settle all this by using Grammarly to have. And then F-like. Sorry, call drop just now. Lagging. Oh. No, my problem. Now I use hotspot. Okay. So, apparatus use or material use in building the model is put. And then apparatus setup. Why the bottle is there? Huh? Just to make it stop, right? This thing will be rolling. But then, the problem is this pipe don't join to the real sink. What Lim sent? Is there a bug in Microsoft Team? Microsoft Team, no stranger to bug and issue. Okay. So, procedure. The cross-sectional area and volume of both 30 cm grey PVC pipe with diameter of 25 mm and 30 cm blue PVC pipe with diameter 20 mm was measured, calculated and recorded. Water supply with a constant water pressure was used to supply water flow into both. But picture, where is the water supply? You don't make all this funny thing, okay? Not logic unless this one is cannot see and then got another picture. That one can lah. Okay. After that, result. Okay, result on diameter, length, cross-sectional area, volume. Volume A times L. Okay, if you don't know how to measure the volume, you measure the diameter first, divide by 2 to the power of 2 times pi. After that, you can measure the length of the pipe. Then you get already the volume. Average time taken, how to take? Can use stopwatch from the phone. Okay. Okay. That's all. But this one last time use Harvard referencing. Now you use APA, okay? Okay. Okay, next we will see. Wait lah. Okay, wait. Why not post? I cannot hear.
To conduct the experiment is Archimedes principle. So here is the model I've created for the experiment. First is the weighing scale.
Can hear or not?
A graduated container filled with 1 liter of water, a spring balance, a straw, and 5 conical metals. So I will use 2 methods to measure the volume force. First
No
is
sound.
direct measurement of mass.
Very
And the
soft.
other is
Okay, wait.
method. Now let's move to the first method to
Cannot
measure the
anymore.
volume force. First, fill the graduated container with 1 liter of water. Then hang the conical metal to
So remember when you record,
on the
don't make
hook
yourself
of the spring
sound.
balance. Now take down the reading and take down the mass of the conical body. Then immerse the
Share already lah the
conical body
audio.
into the water. Then take down the reading again.
Okay, wait. Include computer sound.
Conduct the experiment is Archimedes principle.
Archimedes
So
principle,
here is
okay?
the model I've created for the experiment. First is the weighing scale, a
Here
plastic
nak.
bowl, a graduated container filled with 1 liter of water, a spring balance, a straw, and 5 conical metal. So I will use two methods to measure the buoyant force. First is direct measurement of mass, and the other is displacement
So
method.
mass by,
Let's
no,
move to the first method
not
to
from
measure the
inside
buoyant force.
house.
First, fill the graduated
No
container
need to
with 1
trouble
liter of
yourself
water.
of buying,
Then
okay?
hang the conical metal
You can take any
to
object.
on the hook of the spring balance. Now take down the reading and take down the mass of the conical body. Then immerse the conical body into the water. Then take down the reading again. So to calculate the buoyant force is finding the difference between the weight of object in air and weight of object after immersed in water. The previous step is repeated by increasing the number of conical body. As a reminder, do not allow the metal to touch the side of the container during the process. So that's the end of the first method of measurement. So move to the second method. 1 liter of water is filled into the graduated container also. A bowl is placed on the weighing scale and the initial reading is adjusted to 0. Then a conical metal is immersed into the graduated container. So we can see there's a water displaced. Then we pour into the plastic bowl.
That is
Now,
the
straw
old
is
kitchen
used
scale,
to fine-tuning the water
not
level.
digital one.
We have to make sure the water level in the graduated container is one liter. After that, we measured the mass of the water displaced and convert the mass into the volume in unit. So the buoyant force is calculated by using the equation F equal to 0g. The previous step is repeated by increasing the number of conical metals. That's the end of the experiment. Thank you for listening.
Okay, what you get from the video? Okay, wait, one more.
To start, and I will be presenting about my model for the individual assignment on ESC. Okay, so my model is a hydraulic lift, and it consists of two parts: the hydraulic table lift and the pump, the hydraulic pump.
This one more effort,
which is made by two syringes. Okay, so it is based on Pascal's principle, which says that pressure exerted on an enclosed fluid is transmitted equally throughout the fluid. Okay, so let's move on to how this is made. Okay, so it consists of two equal volume syringes. As you can see here, it's 10 milliliters. Yeah, 10 milliliters, and this is also 10 milliliters. Everything here is strapped onto the base. Okay, it gives support, which is a cardboard again. Okay, so so we need to know how a syringe works. There is the tip of the syringe, and this is called the hub of the syringe, and this is called the plunger of the syringe. This is the tip of the plunger. So the tip of the plunger for that syringe is actually connected and duct taped to a bamboo skewer on the contraption itself, as you can see. And there are the bamboo skewer is actually like so that the ice cream sticks which are connected to it don't move around. They don't tilt, they don't swivel. Okay, so let's see how the table lift is built. Okay, as you can see, there it is primarily built out of ice cream sticks and bamboo skewers. With also the metal wires that is wrapped with plastic, so I do not cut myself. Safety is important. And okay, so the ice cream sticks are connected in like an X sequence, like double X. As you can see here, it's like an X and an X. Here where they're connected, here and here. There's 1, 2, 3, 4, 5, 6, 7, 8. There are 8 points of connection. Okay, so 3 points of connection of each side is connected with metal wires, so it enables it to rotate easily, and the other is connected with bamboo skewers to provide additional support, so it doesn't collapse that easily. Okay, so what you may find interesting is this two thing right here, this two popping thing on the top. Why is it cut in like this, right? Okay, so the answer to that is there is actually a stick here which holds the table lift itself, okay, which is this. It holds it, and so it's support. When it falls, it comes. It doesn't fall completely. Look at this. So it holds in place, and when it is lifted, it follows it. So that is a part where I added, and I feel it's really, really helpful. Sorry, it's a thunderstorm going on right now. Yeah, okay, let's move on. So there is a stud made by cardboard, and it is hot glued to the base. And the bamboo skewer on the other side is actually hot glued to it. So when I push, like so when so how it works is, the principle is like basically this. I'm supposed to push this syringe right here, and it's going to push the fluid all the way right here into this, which will lengthen the plunger. Okay, right now it's really, really short, so it will expand. And when it expands, it's going to push this thing backwards. So this thing is going to be like a clamp. So these two bamboo skewers are going to be like a clamp. And this thing is going to go tall. It's going to be really, really tall. Okay, so now the other interesting thing here is that there are, apart from the table lift itself, there is some like walls, like fake walls, right? So this is to prevent the items which that I'll be placing on later from falling. Okay, so it has a tendency to roll off, but it won't fall. And this, okay, the left and right structure are to make it more stable. Okay, so the left structure is quite tall. Let me just give you a better view. And this thing right here, this slanted cardboard cutout, is to provide support to this, because a straight one is not as strong, mechanically strong as a slanted one. Okay, so with all that being said, let me pause this for a while. Okay, so let the demonstration begin. Okay, so I have switched to my right arm. My left arm is holding my phone. And I will be exerting pressure on this syringe, which will lift this up. Now, there is no weight here. I'll demonstrate again when it has weight. Okay, see, okay, observe. If I push this, which I'm pushing right now, it's going to push the bottom part, which will lift this thing up. Look at this. Eureka! It is moving upwards. Okay, this is the first demonstration without weight. Weight added to it. Okay, so let's move on to our second demonstration, which is with weights. Okay, as you can see, this is an analog kitchen weighing scale. And look closely, it's actually 20 grams because each of this, like one section, consists of 20 grams. So yeah, it's 20 grams. Let's put it over here. And now I'll demonstrate what will happen if I press this. Okay, let's see what will happen. It needs to be in focus. 3, 2, 1. It goes up. It goes up. And away. My creation. Eureka. Okay, so I'm going to add more weights just to prove that this really works. Okay, so let me demonstrate this contraption with 40 grams. See, this is going to be exerted, the pressure will be exerted. Let's see what happens. It goes up, it goes up, it goes up, it goes up, and it works. Okay, so that's all for me. I have demonstrated how it works. I've showed some weight. And yeah, thank you very much. That's all.
Okay, how you find the video? Very good, right? So you must follow the good one. Okay, this is the report which is good also of the same student. Introduction. Chosen fruit principle is Pascal principle. Scientific principle. So he is comparing between figure 1 and figure 2 because he is using the syringe. Connections of a syringe. Measurement of distance travel of fluid in syringe. Okay, I don't know why he need to put two figure. Okay, application. Hydraulic brake system. Okay, where it is applied. In brake system. Hydraulic lift. Okay. As cylinder fills with oil, piston is pushed up, pushing the lift car up with it. Then after picture, talk about it. The third is hydraulic jack. There is one student who demonstrate how the hydraulic jack push up the car, his own dad's car, for submitting this experiment. Okay, up to you. You want to choose that one also can. Piston pump. Procedure. Methodology and result. How he got. Which one? This one this one or the one with the car? This one, of course, A plus Okay, material and apparatus. Witness here why it is not in figures, right? Figures better, no need in paragraph like this. How to read material? Okay. Procedure. Tap water is obtained and colored using red color food dye to enhance its visibility. So if make white color, transparent color, cannot see, right? So he have make it pink color so that it is more visible. One of the shrink is filled up with colored water by placing the hub of the shrink into colored water. Can use watercolor also. No need to use the food dye. Okay. Watercolor mostly have, right, in the school, in the house. Maybe your brother, sister have. And then holes made in the ice cream stick. 6 ice cream sticks are joined together. After that, using bamboo skewer. This one. For the structure. Duct tape, black color. So for him, just the procedure already how many pages, right? Because a long procedure need to make. After that, the cardboard some more. The cardboard dimension with the hot glue gun. You have glue gun or not at your house? If using Uhu, not so efficient. Use glue gun. Go and buy at the DIY. Is the DIY or Daiso, not sure have or not. Plasticine are shaped. This one become bigger, become many pages because all listed in the procedure is very detailed. Picture also very clear and sharp. And then, but only weakness, there are only 2 different object, right? Use 2 plasticine. Only 2 times he measure the weight. Actually, he can make a small shape also. So can become 5 object. Experiment is done very good, but then only using 2 different object. And the size is same. Diameter same. Okay. And then, he have used other mass also. But in the demonstration, only show 2, right? In the demonstration, he explained more on the construction of the prototype. Okay, you must spend more time in the demonstration. Okay, if you inside this table, you have until 200 gram load, but you only show 2, which look a bit the same, the size. Okay. And then calculation, all the calculation already included in the report. And then total mass, force acting on string, cross-sectional area, and pressure. Okay. After that, from the table, he can generate the graph. Graph can be made in Excel automatically, right? Who don't know? No or don't know? Okay, if don't know, never mind. I can show one sample here. Number, item, value. Okay, simple lah. Okay. Then this is the table. Go to insert. Go to chart. Which one you want? This also can lah. Scattered. So this graph come out from this. Okay. And then you can add this. You can change to black. More presentable if the one. This one. Okay. After that, this color. Color if the one blue color also can. Then wait lah. Exist title. Exist title. Can type here. This one. Why the red don't come out? Data label, this one will come out. 70, 30, all this. Trend line, error bar, no. Okay. So here can be color. X-axis is always the non-depending. Y-axis depending. Okay. So value here can choose value versus color. Okay, if you don't want blue, can choose other color also can. Okay. Then if the one scattered, go to insert. You can go to this. This also can. Any style you want also can. But provided the table is there, you copy the table, then the graph come out. Copy the graph and put in the report nicely. Easy to copy. Just copy this. Control C. Go to okay, Control V. Then adjust it nicely and don't be so big. Okay, sample like this. Okay. So now now we will see another experiment.
Good morning, and I'm Kifashan. Today I'll be explaining about my model, the model that I've designed for engineering science assignment. So as you can see here, this is a very
Can
simple
hear.
hydraulic system, which I've made from 2 syringes and a silicone tube. All of these materials can be bought from
Yes,
hardware stores
miss.
such as Mr. DIY. This is the first syringe, and I've named it piston 1. The first syringe has a radius of 1.2 centimeters, and this is the second syringe, a larger one. The piston 2 has a radius of 1.5 centimeters. So I've designed this experiment in order to demonstrate Pascal's principle, which states that for when a pressure is applied
So
to a
whatever
liquid
model that you have
contained in
made, don't show your friend.
an
Later it will
enclosed
look
container,
about the same.
the pressure is transmitted throughout the liquid in all directions equally. So this syringe, when I press on this syringe here, it will compress the fluid, the water in this syringe here, and it will cause a pressure which will then be transmitted through this silicone tubing all the way to piston 2, which has a larger radius and hence a larger surface area. And then the larger surface area here, since the pressure is maintained between the two pistons, the larger surface area here will need a larger force in order to balance out the pressure. Hence, it will produce a larger force, which will enable the piston 2 to push up heavier objects. So I will now do a very simple demonstration of how this system works. As you can see here, when I press onto the first syringe, it will compress the liquid here. Okay, as it compresses the liquid, it causes a pressure to flow through the tube all the way to piston 2. And as you can see, when I press onto the first piston, piston 2 slowly rises as well. So this shows that for a contained liquid in an enclosed container, the pressure travels throughout the whole system equally in all directions. And that is all for my recording. Thank you.
Okay, simple or not? Which one you think better? Just now one only use one piston, right? This one two piston, even though both are Pascal principle.
Good morning, Miss. This is my experiment that I made to prove Pascal's principle, and this is the larger syringe which will support the larger weight later on, and this is the smaller syringe which will support the smaller weight. So this is the tube that connects both the syringes to ensure the flow of the water. And as can be seen here, 2 cardboard boxes have been pasted on the base of the syringes to ensure that it can hold the load. So now this is a soap bottle of weight 0.5 kg, and this is a soap bottle as well, a shampoo bottle of weight 0.9 kg. So this will be the smaller, the F1, which is the smaller weight, and this will be the F2, which is the larger weight. So now I will be placing the experiment like against the table to ensure the smooth flow of water. And now I'll first be placing the larger weight on the syringe, the larger syringe. I'm just holding the larger weight to ensure it's not falling, but I'm not adding any additional weight, so it won't affect the results. And
because the frame
now
is
I'll
soft,
be placing
right?
the smaller weight to see how much the larger weight rises. Once again, I'll be just holding the smaller weight as well because, you know, to ensure it doesn't fall because it's quite a weak model. So here we go. I'm not adding any additional weight or force. I'm just holding it for support only. So let's see how it goes. It's moving quite slowly for now. So let's see. But as can be seen, it is moving and the F2 is rising due to the weight produced by F1. Let's see how it's going. As can be seen, F2 is still rising. I'm just holding very lightly. So place it straighter and now it's going faster a bit. It's flowing. It's moving very slowly, but it's still moving. I'm just holding very lightly as you all can see. Looks like F1 is going to finish, but F2 is not rising anymore. So this is all I think that it moves. Let's just wait for all to see if any difference. And not so. Now I'm gonna lift F1 first. I mean F2 first, then F1 to the side. And as can be seen, F1, which was full earlier in displacement, is now reduced, and there's lesser water in the smaller fringe, and the water has flowed to the larger fringe, and as can be seen, it has risen a bit. It can be clearly seen that this weight is heavier than this, and this was able to lift the larger weight. So through this experiment, even though there's still a bit left, which I don't think is supposed to happen, it can be said that the experiment was proven because there could be possible air bubbles inside the tube or the fringes as well, which could affect the results and the flow of the water. Hence, the pressure of the liquid wasn't distributed equally and could cause these irregularities. And also, as can be seen, the board is not clearly very strong and bends very badly when the weights are placed. So, and that's about it. This is my model for Pascal's principle, and this is the difference it makes when the larger weight and the smaller weight are placed on the larger fringe and smaller fringe respectively. So yeah, that's all for my presentation. Thank you very much.
Okay, what is your feeling after looking at this presentation? No feeling. Yeah. Yeah. Product. Wait ah.
I will show how Archimedes principle works by experimenting it. For the experiment, today we need a spring balance, overflow vessel, beaker, beam balance, jug and a potato. At first we have to take some water in the jug, which I have here. Then we have to have the overflow vessel connected with the beaker. And this is the overflow vessel and this is the beaker which I have connected. And then we have to pour some water in this overflow vessel. We have to fully fill it up. And thus it will display some water from it. When the flow of the water stops, then we have to take this spring balance and wet this potato in the air. Here is the potato and I'm measuring it. It's in pound now. I will change it to kg. Yeah, now it is in kg. And it shows that it is 0.12 kg. And now we have to submerge the potato fully in the vessel. Before that, we have to move the water from this beaker. Keep it in the same position again. Now we will submerge the potato fully in this overflow vessel. And when the water flow stops, we need to take the beaker and pour the water in this beam balance. Here we can see the weight of the displaced water is 0.12 kg, which is exactly the same as the weight of the potato in air. The principle of Archimedes tells us that the weight loss is equal to the weight of the displaced fluid of the object. If the object has a volume, it transfers the volume of the liquid when it is completely submerged. If only a portion of the volume is submerged, the object can only transfer a small portion of the liquid. In simple terms, the Archimedes law states that the buoyant force of an object is equal to the weight of the liquid transferred by the object. It can be measured by the following formula: weight loss equal to weight of the displaced fluid. And thus we can say that our experiment completely matches with the principle of Archimedes, which is weight loss equal to weight of the displaced fluid. Thank you so much.
Okay, so there are some of the students who do another type of experiment, right? Okay, wait ah. This one is another style.
Hello, my name is Kim Min-jun, and this is my individual assignment for ESC. Today I will be showing you how Archimedes' principle works with only just a simple objects like these. So, first we have a container which is filled to the brim here and here. And we have an object over here that lifts the container up from here, and it goes slanted like this, so that the water, when an object is put inside the water has only one way to go out. And we have a container inside here so that it collects the displacement of water. And this is an object which is going to be submerged into the water so that the water inside the bucket is going to be displaced. And we will show you that now. And we can say that I have let go of the object and the water is slowly getting displaced. But the level of water is not changing. The level of water is not changing, but the displacement of water is going down. Once the displacement of water has been completely done, we can see that the level we started at is still the same, but there's an object with, let's see, it's floating, so that means that it has less density than water. After, we can put the displacement water into a measuring bottle or a measuring flask. And if we see here, it will say around 100, around 110, somewhere around there. And with this, we can convert this milliliters into kg, which is going to be 0.11 kg with just density and volume of water. Now with 0.11 kg, we can say that the weight of the displacement water is the same force of buoyancy that acts upon the object. So if we see here, the thing that pushes down is gravity, but the force that acts upon upwards is called buoyancy. And if you see that the object is not sinking and that is due to positive buoyancy, meaning that there is positive, buoyancy force that acts upon than the gravitational pull. There's also a saying that the volume that is submerged below the waterline, the volume of that, is the same volume of water displaced. So, if the object is floating like this, then the part of the object that is submerged into or below the water level, that volume is the same as this volume. But if we see here, there is only a small portion of the object that is actually floating, and this volume is the same as that. And that is it for my demonstration. Thank you very much.
Okay, from what you observe, you can use any of the product in your house, right, to do the assignment. No need for you to order things. Okay. Okay, next.
Individual assignment, and I will be briefly explaining about the fluid principle. So the fluid principle that I have chosen is Archimedes principle. First, I have a 15 centimeter ruler with the 0 centimeter mark over here. Next, I have a rock tied to a rubber band and to a chopstick. Here I have marked the edge of the stone, and I have a measuring cup filled with water here. So first I will measure the length of the rubber band, and it is 15 centimeters. Next, I will submerge this rock in water and measure it. Now, as you can see, the mark on the rock is slightly above the 15 centimeter mark, showing that the rock is being pushed up by an upward or buoyant force of the water. And next, for the model, we have the same rock, a watering cup with a hole here, and when it overflows, the water will flow into the hole. And next, we have the same measuring cup. And a water-filled balloon. So first, I will measure the mass of the rock.
So this is the kitchen digital scale.
As you can see, it is 76 grams. And next, I will fill the measuring cup with 100 milliliters of water. I will measure the volume of the rock using the water displacement meter. And here the mark reaches 130 milliliters. So the volume of the rock is 30 milliliters. And next I will fill this measuring cup with water again. And I will pour this into a watering cup. Now that the watering cup is filled with water, full of water, I will put this whole into the measuring cup. And next I will put the rock into the watering cup. And as you can see, the mark on the measuring cup is 30 milliliters, proving that this watering cup is accurate. And now I will pour the water back. Next, I have filled the measuring cup with 190 milliliters of water. And I have a water-filled balloon. And I will measure the volume of the water balloon. And the measuring here is 250 milliliters. So that means that the volume of the water balloon is 60 milliliters. Then next I will measure the mass of the water balloon.
So you can see the experiment, quite a lot of effort, right? Got two different objects. One is the rock, one is the water balloon.
As you can see, it is 71 grams. And next I will fill the watering cup back until it is through this. Was 294.3 newtons, which means that the rock was much heavier than the weight of the water displaced, and so the rock sinks into the water. And in the second example, the water balloon has a weight of 696.51 newtons, while the water displaced by the balloon was 588.6 newtons, which is not much difference. So there is a upward or buoyant force lifting the water balloon up. So how can the model be applied in real life? ships are designed so that its weight is equal to the weight of the water that it displaces from the ocean, just like the water balloon over here.
Okay. So that is all sample of students' assignment with you. Okay, so now we will take our attendance. So try to make a good standard of assignment. As you can see, the sample just now quite detail, right? Whatever they do. Okay, because the time given is a lot already. Already like 1 month. So try to have a good review. Maybe you can do some video and ask your friend to review, but not the same class. Okay, give to other student or other friend to review. Because I don't want to see the same experiment done by the same class. Even though it can be coincident, but the model will be slightly the same. Will be slightly different, suppose. Okay. If you are using syringe can be different size. If you are using same size, then the experiment will be different. Okay, scan your QR code. 551, the code. Okay, so during weekend, you can go to Daiso or DIY to get suitable items. Like the measuring of liquid jug just now, got measuring, right? You can find in the Daiso. Daiso sells small items. Okay, thank you all. Good luck to finish up your report.
Okay, thank you, Miss.
Okay, thank you.